Okay, so this is the Chapter 8 review. In 1, 2, 3, and 4, we have proportions to solve. And anytime you have proportions to solve, you cross multiply. And so I have 2, 6 equals negative 4 over m. Now, the negative only actually just applies to the 4 or the m, but doesn't apply to both. So I'm going to have it just apply to the 4. So when I cross multiply, when I multiply these, I have 2 times m, which is 2m. And then I have 6 times negative 4, which is negative 24. Then I'll divide both sides by 2, and get that m is equal to negative 12. Number 2, I'm going to do the same thing, except they have more complicated expressions here. So I'll have 10 times the quantity a minus 2, and 8 times a, or 8a. 10 times a minus 2, if I distribute, that's 10a minus 20. That still equals 8a. Oof. If I subtract 10a from both sides, that's 8a minus 10a, which is negative 2a. Divide by negative 2, and I get that a is equal to 10. On 3, again, cross multiplying. 4 times the quantity x minus 8, 8 times the quantity x minus 6. Distribute. 4x minus 32 and 8x minus 48. Subtract 4x from both sides. That's 32, or negative 32 equals 4x minus 48. Add 48. That's 4x equals 16. Divide by 4, and x is equal to 4. Number 4, again, same thing. Cross multiply. That's 6 times 7n minus 8, and 5 times 2n minus 5. Distribute, that is 42n minus 48, that is 10n minus 25. Subtracting 10n, that's 32n minus 48 equals negative 25. Adding 48, that's 32n equals 23, and dividing by 32, 23 divided by 32 is 23 over 32, or the decimal 0.71875. On number 5, we're supposed to solve for x, and the polygons here, the shapes here, are similar. So anytime you have similar shapes, you should have their corresponding sides be proportional. So this 15 corresponds with that negative 3x, or sorry, negative 3 plus 2x, because these are the shorter lengths on the parallelogram. That 25 corresponds to the 15. So these corresponding sides should be proportional like this. So we solve this using cross multiplication. 15 times 15 is 225, and then I have 25 times negative 3 plus 2x. If I distribute that 25, it's negative 75 plus 50x. I'll add the 75 to get 300 equals 50x. and I get x is equal to 6 when I divide by 50. In number 6, it's a little trickier to find matching parts, and there's a lot more corresponding parts here. So, from what I can tell, this is the shortest length here, right, in this shape, and that's a 4, and this 8 is clearly the shortest length on that quadrilateral. So I'll compare 4 over 8. That should be proportional to this 2x minus 10. It looks like the longest side on the left is proportional to the 16. Notice how I went from shape on the left to the right, 4 to 8, and I need to continue that to be 2x minus 10 over the 16. Cross multiply. 4 times 16 is 64. 8 times 2x minus 10. Distribute the 8. 16x minus 80. Add the 80 is 144. Divide by 16 is 9. X is equal to 9. In 7, 8, 9, and 10, I need to say if the triangles are similar or not. If they are similar, state how I know they're similar, and complete the similarity statement. So there's 3 options for proving triangles or showing triangles are similar. There's AA similarity, where you have 2 pairs of equal angles in the triangles. That's enough to show that the triangles are similar. There is side, side, side similarity, where you have 3 pairs of sides proportional. That's enough to show that triangles are similar. And there's side angle side similarity, where you have 2 pairs of sides and an angle in between. 2 pairs of sides that are proportional and the angle in between are equal. Let's take a look at number 7. Number 7 doesn't have any side listed, like any lengths listed, so it's probably not either one of these. It might be angle, since they have angles marked here. So let's try to find 2 pairs of angles that are equal. Angle B from the small triangle, from this small triangle, is equal or congruent to angle B from the big triangle through the reflexive property. So that's 1 pair of equal angles. This angle MNB is 82 degrees, and this angle B is 78. Okay. If these triangles are similar, those 2 angles should have been equal to each other. So since those are not equal, it's not angle-angle similarity. These triangles are not similar. Since they're not similar, I don't have to write their similarity statement. Number 8. So this looks like there's some sides in there. It's definitely not side, side, side similarity, because I have 2 pairs of sides and I don't have a 3rd pair. So this might be side angle side similarity, where we have 2 pairs of equal sides, or not equal sides, proportional sides, and an angle that's equal. Angle LJK is congruent to angle RJQ. Those are vertical angles there. So I have the angle part down. I need to check to see if the 2 pairs of sides are proportional. So if I go with 81, I need to find the side that is corresponding to it, that matches up with it. 81 in the triangle at the top is the smaller of the 2 sides. So I have to look down here and find the smaller of the 2 sides to see which one matches. 9 is the smaller of the 2 sides. 81 divided by 9 reduced is 9. I want to check to see if the other pair sides are the same. So 126 and 14 are the corresponding sides. 126 divided by 14 is also 9. So those 2 sides are, 2 pairs of sides are proportional. So I have these 2 sides being proportional to those 2 sides, and angles in between. So yes, these are similar by side angle side similarity. The similarity statement, triangle JKL, is similar to triangle J, Q matches with K, R matches with L. Number 9 looks to be about the same. It looks to be side angle side similarity. Again, these are vertical angles here. They're congruent. But let's check through, see if the sides are proportional. Again, if I pick 36, that's the larger number from this triangle, I should match it up, or it should correspond with 20, which is the larger side from there. So 36 over 20 is 1.8. If I reduce that, or if you like decimals, that's 13 over 10. Not 13, 18 over 10, which is 9 over 5. If I reduce the other ones, so 26 over 15, 26 divided by 15 is 1.73 repeating. If I reduced it, if you just like to deal with fractions, that still is 26 over 15. That doesn't reduce. These aren't the same fractions. These aren't the same decimals. These aren't the same proportions. So it turns out these sides are not proportional. So it's not side angle side. So these are not similar, because the sides aren't proportional. Lastly, number 10. It gives me 3 pairs of sides. So it looks like it's going to be side, side, side similarity. But again, just like from the last problem, we need to check to see if they are all proportional. So let me pick 8 to start with from the top triangle. 8 is the smallest side here, the shortest side. That should correspond to 16 because that's the shortest side here. 8 over 16 is 1/2 or 0.5. I want to make sure all these sides have the same ratio. Go with 10, that's the middle kind of side. 20 is the middle side over here. 10 over 20 is 1/2 or 0.5. Pick 13, that corresponds to 26. That's also 1/2 or 0.5. So yes, all these are proportional. So it is, triangles are similar by side, side, side. So triangle JKL is similar to triangle, let's see, J and 20 is the middle, so T and U. On the back, they tell me the triangles are similar and I need to solve for x. So anytime you have similar shapes and you need to solve for a missing length, you're going to need to set up proportions. You need to find corresponding parts that match up, or corresponding sides that match up, and set them equal in a proportion. So 10 is, if you look at strictly at that triangle, 10 looks about the longest side. You need to find the corresponding side to it. If you look at the triangle on the right, 20 is the longest side. So 10 and 20 should match up. And 7 should correspond with 4x plus 2. Cross multiply. 20 times 7 is 140 equals 10 times 4x plus 2. Distributing the 10. So 10 times 4x is 40x, 10 times 2 is 20. Subtract 20 and divide by 40, x is equal to 3. In 12, they have 2 overlapping triangles. So I like to just draw 2 separate pictures for that. In 12, so there's a big triangle, that's 14 and 20. And there's a smaller triangle, that's 7 and x minus 2. Separating them allows me to see which the matching or the corresponding parts a little easier. So 14 corresponds to 7, and 20 corresponds to x minus 2. Cross multiply, 7 times 20 is 140. 14 times x minus 2. Distribute. 14x minus 28. Add 28. And 168 divided by 14 is 12. On 13, these are parallel lines here, so I don't need to draw two separate triangles when I have parallel lines and I'm comparing these sides. They should be proportional. Like 12 over 27 should be the same as 16 over 10x minus 4. And cross multiply. 27 times 16 is 432. 12 times 10x minus 4. Distribute. Add 48. And divide by 120. And get that x is equal to 4. Okay. So in 14, I can do this a couple of different ways. Since these are parallel lines, right here, I can say that these parts are proportional. This is 12, that's 8, and this has to be 4. So I can just go with 5 over 4 is equal to x plus 1 over 8. Cross multiply 5 and 8 makes 40 times 4 equals 4 times x plus 1. Distribute. Subtract 4. And x is equal to 9. In 15, this is an angle bisector. So when you bisect an angle like that, these parts here are proportional. This 5 to the 10, and the 2x minus 12 proportional to the 4. Again, cross multiply. 5 times 4 is 20. 10 times 2x minus 12. 10 times 2 is 20x. 10 times 12 is 120. Add the 120 and divide. X is 7. In 16, again, these are parallel, so these sides should be proportional. 9 over 6 is proportional to 4x minus 4 over 8. Cross multiply. 9 times 8 is 72 equals 6 times 4x minus 4. Distribute. 24x minus 24. 72 plus 24 to both sides is 96. Divide by 24 is 4. In 17, there's a woman. She's 5 foot tall. Casts a shadow that's 7 feet long. At the same time, a light pole casts a shadow that's 35 feet long. How tall is the light pole? And that's x. So these create similar triangles. They're both right angles here, and this angle is the same as that angle. So because these triangles are similar, I can solve this using a proportion. 5 over x should be equal to 7 over 35. Cross multiplying, that's 7x equals 5 times 35, which is 175. Go ahead and divide by 7, and x is 25. So the light pole is 25 feet tall. So in 18, a mirror is placed on the ground, so the person looking into it can see the top of the building. The person is 150 centimeters tall and 6 feet from the mirror, so there's 6, not feet, so meters. And tower and the mirror. So there's a tower here, and the mirror is 120 meters away from the tower. This person is 150 centimeters. So when we solve for x, we're going to get our answer in centimeters. Again, these create similar triangles. This angle is equal to that angle, and these are both 90 degrees. So 150 centimeters matches up with x centimeters for the tower. Should be the same proportion as 6 meters over 120 meters. So that gives me 6x equals whatever 150 times 120 is. And that's 18000. Divide by 6. It's just 3,000 centimeters. If you cared at all, that's 30 meters. If you want everything in meters.